students. So today I am standing before you to explain you the section formula, which is the next part of your coordinate geometry as per your syllabus. So today's lecture is totally based upon to make you understand how to use the section formula in getting the solution of your exercise problems given in your NCERT book exercise 7.2. So let us understand first what do you mean by this section formula. In previous exercise we have spoken already about the distance formula, where we determine the distance between the 2 points A and B, and I said chord of A are x1 and y1 and chord of B are x2 and y2. Then we applied the distance formula to determine the length of this AB. Now at the same line, if I mark any point P here, suppose, what happens? This join of AB is getting divided into two sections. You can see very clearly. First is your A to P and then second is your P to B. Or in other words, I can say that this P is dividing join of AB in a fixed ratio, that is the internal ratio. So I will say M1 ratio M2. So this is AB is M1 and PB is M2. And I want to determine the chord of P, which divides the join of AB in the ratio of M1 ratio M2. So here is X, here is Y. Now count the number of variables I am using all here in this diagram. 1, 2, 3, 4, 5, 6, 7, 8. So 8 variables at a time are there. Now out of these 8 variables, if 7 are given to me or 6 are given to me, I can determine the other 7 or 6. So out of 8, if 1 is given, I can determine the other 7. Out of 8, if 6 is given, I can determine the other 2. And to get those unknown variables, the formula which I am using is called the distance formula. Suppose I am talking about I have to determine the value of x, that is the chord of P, abscissa of P, which divides the join in the ratio of M1 ratio M2. So this will be M1 x2 plus M2 x1 divided by M1 plus M2. So whenever I am talking about x, I will be using the formula in terms of x and M1 and M2. If I want to find y, so then I will be writing M1 y2 plus M2 y1 upon again sum of the ratio, that is M1 plus M2. Now count 1, 2, 3, 4 and again 2 same are there, and this is the fifth one. So you can determine x, you can determine y by using this x1, y1, here it is x1, or in case of y it is y1. When I am talking about x, I will be speaking about x part only, x1, x2, x1, x2, m1, m2 and x I am determining. Then if I need to determine y, in terms of y only and m1 and m2. So this formula to find the value of x and y or some other, in these terms when I am using this, is called the section formula. So now you see here, derivation is also there. You can see in your textbook it is given, or at the later stage I just will give you the derivation, that is somewhere is the sum of your areas of trapeziums, and again there is a right triangle to come into this picture, or how we can use this. Now the simple application part, from the application point of view. So I am speaking, if you need to determine the value of x, directly you can use this formula. If you want to find the value of y, again directly you can use this formula. Substitute all these values will be given to you, like in your exercise 7.2. If you go through the first question, find the coordinates of the point which divides the join of. Join of means it is minus 1 and 7 given, and 4 and minus 3 given, 4 and minus 3, which divides this join in the ratio of 2 and 3. So now very simple, I am given with x1, I am given with y1, I am given with x2, y2, what is m1 and what is m2. Simply I have to substitute all these values of m1, x2, m2, x1, m1 plus m2, similarly y2, y1, m1, m2, m1 plus m2 to get the value of x and y. So this is called the direct application. Question can be there in section A or section B maximum. This question will not be falling in even section C. So direct application when is there, that you can understand from the basic paper point of view. And in standard, there will be a small twist that you can see in the coming questions of your exercise. But my today's talk is related to make you understand specially that what is section formula and how to use this formula. Now second part, if you see somewhere, if all the other chords are given, x is given, y is given, x1 is given, y1 is given, x2 is given, y2 is given, then you have to determine the ratio. So when to determine the ratio, then you need to pay attention. This is a very important instruction. When to determine the ratio in those particular questions. Let the ratio be k ratio 1. Let the ratio be k ratio 1. Means in that case, I will not be taking m1 and m2, or if you are writing in terms of m1 and m2, you can write m1 is equal to k and m2 is equal to 1, or join of AB by this point P is divided in the ratio k ratio 1. So here what I did, I have reduced the two unknown variables now from 2 to 1. From 2 to 1. Now why is it so? Make a note of that. You remember, your ratio according to your syllabus is internal. It is not external. It is not going to be extended towards B or towards A. Neither forward nor backward. So no chance that your answer in any of the way will be negative. All the times your answer, that is the ratio whenever you are going to determine, will be positive. So if k suppose is coming 2, so my answer will be 2 ratio 1. If k is coming like 3 upon 4, so my answer will be what? 3 ratio 4. So no need to take two variables. I have reduced from 2 to 1 simply to get the value of k. So k, if I am getting in terms of the single number, so I can put in the denominator 1 to write my answer. If k is equal to 3 upon 4, I can write my answer, that is there in the ratio of 3 ratio 4. And then how to use the formula? Then you are writing x is equal to what? I said m1 x2 plus m2 x1 upon m1 plus m2. So you look at your question number 2, like find the ratio. Question number 4 I am saying, find the ratio in which the line segment joining the points. Joining the points means, now here joining the points, this chord is given minus 3, this chord is given 10, and 6 and minus 8, this chord is given 6 and this chord is given minus 8. So is divided by minus 1 and 6. Here it is minus 1 and here it is 6. Then you have to find the ratio. Means I have to find the value of m1 is to m2. So m1 and m2 I have already reduced in the ratio of k ratio 1. Now m1 is k and m2 is 1. So here in place of m1 you need to write k. In place of m2 you need to write 1. So what it becomes? kx2 plus kx1 and k plus 1. I hope you followed what I said. This is m1, m2, m1, m2, m1 plus m2, k plus 1. m1 means k x2. Now you substitute the values. What is x in here? That is minus 1 is equal to k. What is x2 is? That is 6. So I will substitute 6. Again k, x1 is what? Minus 3. So that is minus 3. And it is k plus 1. I hope all of you can do these calculations as per your own convenience. If you cross multiply, minus 1 into k plus 1 is equal to, this is 6k minus 3k. So minus k plus 1 is minus k minus 1 is equal to, this is 3k. This is, you can shift it to this side, minus k minus 3k, that is equal to plus 1 minus 4k is equal to 1, or k is equal to minus 1 upon 4. So now you make a note of this, please. I said this cannot be negative, means some mistake we have committed somewhere. So please look into that. This is minus k minus 1, 6k. So minus k minus 3k, and this is 3k here. And if I shift this to this side, this is minus 3k, and this to this side is plus 1k. Again, let us see somewhere what is the mistake. So x is equal to minus 1. This part is already given minus 1. m1k, x2 is 6. x1 is minus 3k plus 1. So minus 1 into k plus 1 is minus k minus 1. And if I cross multiply there, here it is 6x2. That is k minus x1, x2 and x1, x2 and x1. So this is 6 and this is minus 3, 6 and minus 3. So please check. I don't think the answer can be there in negative. Minus k minus 1, 6k